This is Josh White with JW Math Tutoring. Today's video is going to focus on the October 2023 SAT QAS, specifically the No Calculator part, section 3 of the math portion of the test. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
All right. Just before I get started going through the no calculator section from the October 2023 QAS, the math part of this SAT exam, just a couple things to keep in mind. Of course, if you like this video, please do give it a thumbs up. And of course, subscribe to my channel, sign up for notifications. Second, a lot of these problems have multiple ways that you can solve them. And I usually tend to go through as many ways as possible. So this video will most likely be longer than the allotted time that you would have had to complete this test. And that's just because, like I said, I like to show multiple methods to solve these problems. And of course, also check out the solutions to the calculator section of this exam on my channel as well. All right, so that being said, problem number 1, here we have a graph. It's actually an exponential function. And we're asked to find what the mass of this sample of sodium 24 is at 5 hours. So we're just going to the graph, going to 5 hours, going to find what its y value is on the graph, which is going to be 40. So correct answer is just letter C, 40, and that's it. We're just reading this graph, not doing anything else. Next, we have an absolute value equation here. So the way you would typically solve an absolute value equation is you set up two different equations. The first one looks like the original, just no absolute value signs. The second one looks the same on the left side, but you make the right side opposite, or in this case, negative, -6. Then you solve each of them and you technically get two answers. However, this one only wants the positive solution. So if you notice, once we solve the first one, we get x equals 3, which is the positive solution. So correct answer is going to be B. We don't have to bother solving the other equation to get the negative solution. However, this one could also be solved using back solving. And what I mean by that is just take the answer choices and plug them in. 2 plus 3 is 5. Is the absolute value of 5 6? No. 3 plus 3 is 6. Is the absolute value of 6 equal to 6? Yes. Correct answer, and so on. So anytime you have an equation, you should always look and see if you can back solve it as well. All right, now for number 3, you are given the equation of a line and you're told to find its graph. So a couple things here. Notice that the slope of this line is going to be negative. If you rewrite it, it's just y equals negative x plus 4. So the slope is -1. Y-intercept is positive 4. Okay. Answer choice A is out. It has a slope of a positive value, so it cannot be the answer. B we will keep for now. C has a positive slope, get rid of it, and D has a negative slope. So far B and D are the two possibilities. And now we want to check and see, okay, which one has a y-intercept of 4? B clearly does, so that's going to be the correct answer. And then if you look down here at D does not go through positive 4, it instead goes through -4. So it is incorrect, and we would eliminate it. Moving on to question number 4, here we have a system of linear equations, and you're asked to solve this. So because the top one is already isolated for y, I'd probably recommend doing substitution on this problem, because you can just go ahead and plug in the 7 minus 4x in place of the y in the second equation. So when you do that and then distribute, you're going to get 15x minus 28 plus 16x equals 3. 31x minus 28 equals 3. 31x equals 31 because we add the 28 to both sides. And so x is just going to equal 1, divide by 31. Notice so far, this cannot be the correct answer. This cannot be the correct answer. We're now down to two choices. So at this point, probably just go back to the first equation, plug in the value of x that we got. 7 minus 4 times 1, well, that's just 7 minus 4. So y is going to equal 3. Correct answer is going to be letter C. You could also back solve this one, meaning take an answer choice and let's say the easiest way would be take the x value. So for a, it's negative 31. Plug it into the first equation. Okay, 7 minus 4 times negative 31. And then see if that gives you the correct y value. If it does, then you would plug them both into the second equation and see if they work. If they don't, then it's not the right answer, and you'd move on to the next one. So you could back solve this one, but as you can see from the work, it's probably quicker just to go ahead and do substitution and solve it out, the traditional way. All right, question number 5, we have a system of linear inequalities, meaning we're graphing two lines and then we're going to be shading both of them. So there are multiple ways you could do this one. If you notice, first of all, in the graphs, okay, all the lines appear to be the same. So we cannot eliminate any answers based on a line, say, having a wrong slope or a wrong y-intercept. So instead, we're only going to eliminate answers based on the shading of each of them. So, for example, I'm going to pick some test points, and let's say for the top one, I'm going to pick 0, 0. Okay, so if I plug that in, I get 0 is less than or equal to 2 times 0 plus 3. 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. Okay, so that checks. So for the line y equals 2x plus 3, 0, 0 works in it. That means I need to be shading in the region where 0, 0 is located. All right. Now, we do have to look at these graphs and identify which of these two lines is y equals 2x plus 3. Well, notice the second one, I mean, it's an inequality, but we're really just, looking at the line part of it. Notice the second one is 0.5x minus 6. That one is going to have a negative y-intercept of a negative 6, so that one's going to cross below the x-axis. This one obviously has a y-intercept of plus 3, so this one's going to cross above. So the equation, or the line, excuse me, that corresponds to the top inequality is going to be this steeper one that I'm highlighting in yellow. Notice 0, 0 is on the bottom right of that graph. So what that means is, since 0, 0 works, the shading for the top one is going to be basically this part right here. Okay? So it's going to have to be on this side of the line. So if you color that in, notice the only two where I have overlap of what I just shaded and the answer are B and D. Okay? A is shaded on the other side of the line, so that's out. C is shaded on the other side of the line, so that one's out. Now, looking at the other one, if I plug in the same point, 0, 0, 0 is greater than 0 minus 6, 0 greater than or equal to negative 6. That is a true statement. That means for the other line, which I'm going to trace out in green here, I'm going to shade above it because 0, 0, right here at the origin is above the line. So that means I'm going to shade, above this line. And therefore, the overlap, where the yellow and the green overlap, it's basically this region right here, kind of this, almost like triangular region. The correct answer is going to be B, and now I'll just erase, when you see it, when I erase all the colors, you can see which one matches. Okay, you can clearly see B is the one that has the shading overlapping where I had it. So the correct answer for this one is going to be letter B. Also note that when you have like a linear inequality here, if you have the y on one side alone by itself and everything else on the other side, then what's going to happen is if it is less than, you shade below the line. If it is greater than, you technically shade what you'd say is above the line, and that holds in this case. This top one here is less than, so we shade below the line, or technically it's like bottom right. And this one is greater than, So you shade above it, and then we can see the overlap. So you technically can do it without test points, but the key is the letters have to be on their own. The Y has to be alone by itself, everything else on the other side in order to use, basically to use that shortcut. All right, number 6, we have a function, and they want to know how much did the worldwide production increase from 2010 to 2011. So notice from 2010 to 2011 is 1 year, okay? And time, or years, is the equivalent of the x variable in this function. So if you're increasing the x value by 1, or making the change in x equal to 1, your change in y is just going to basically be equal to the slope. Because the slope, when you have it written in a linear equation, is equal to basically the change in y, the change in your output variable, per a 1 unit change in x. So therefore, the answer is just going to be 0.17, because basically 0.17 is like 0.17. This is the slope right here. It's like 0.17 over 1. Okay, so if the x changes by 1, which is what they're asking for, 1 year, then the top, the y, has to change by 0.17. So correct answer is just letter A. All right, for number 7, we have a linear equation, and they want to know which one has no solution. So for a linear equation to have no solution, what we need to have is basically the same variable terms on each side, but different number values. So if you multiply all these out, notice on the left, you're going to get 4x plus 4, okay? For A, you get x plus 4. Here, the variable terms are different. One is 4x, one is x. That means this will have a solution. Same thing in B. 4x plus 4 equals x plus 1, okay? Again, the variable terms are different, so it will have a solution. In C, you get the same thing on both sides for both the numbers and the variables. In other words, if you tried to solve this, everything would cancel out and you would just get 0 equals 0. And this is what happens when it's infinite solutions, or sometimes also all real numbers. It's D, which is 4x plus 4 equals 4x. When you try to solve this out, if you move the 4x over to the right, you get 4 equals 0. That is never true. There's no value of x that you can plug into the equation to make 4 equals 0. Therefore, D is the one that is no solution. Again, same variable terms, 4x, 4x, but different number terms. On the left, it's 4. On the right, it's not written, but it's, it's still there. It's 0. Next up, number 8. So here we have a function, and it's in its factored form, x minus 1 times x plus 1 times x plus 2, and it says which of the following is not an x-intercept. So remember, an x-intercept, a root, a solution, these are all points like on a graph where basically the y value, or the y coordinate, is 0. So it's like if you set this equal to 0, and then you go ahead and solve it by just, setting each factor equal to 0, hopefully you'll recognize your 3 x-intercepts are going to be x equals 1, x equals -1, and x equals -2. So we've got 1 here that is an intercept, we've got -1 that is an intercept, and we've got -2. So which of these is not an intercept? It is D. 2, 0 is not an x-intercept. All right, for number 9, this one there's multiple ways you could do this. So if you're familiar with the rules of exponents, basically you can first rewrite this as 16 to the 1/2 to the x power. You can split up the 1/2 times x. 16 to the 1/2 is the same as the square root of 16. And the square root of 16 is, of course, just equal to 4. So this simplifies to 4 to the x. So the correct answer is A. However, you could also use the strategy of picking numbers for this. And here's how you could do it. I'm going to let say x is equal to 2. If you plug that into the expression, you get 16 to the 1/2 times 2. Well, 1/2 times 2 is 1. 16 to the first is 16. Now, when you go through all these answer choices and you plug in 2 for x, which one of these gives you 16? So A is 4 squared, 16. It's correct. B is 8 squared, which is 64. Not correct. 8 times 2 for C is 16, so that one you would technically keep. And D is 16 root 2. Okay, obviously not correct. Now at this point, what I would do is I would have to repeat picking numbers, but now I would maybe let x equal 0. So 1/2 times 0 is 0. 16 to the 0 is 1. So now 4 to the 0 is 1. Okay, that matches. 8 times 0 is 0. That does not match. So you could also use picking numbers to figure this one out, but the correct answer is going to be A. For 10, we have some similar trapezoids, and basically what we have going on here is each side of PQRS is 3 times the length of ABCD. So that means the scale factor, between them is basically like 1 to 3, or I mean 3 to 1 if you're looking at the large to the small. Now, area is two-dimensional. When you're calculating an area, you're basically multiplying two dimensions by each other. So that means the area of the small is 6. Okay. The area of the larger, it's not going to be 6 times 3. It's going to be 6 times 3 squared. Okay. Because each side is 3 times as large. So since it's two-dimensional, that's why you have to take 3 and square it. So the area of the large is going to be 54, or 9 times the area of the small. It doesn't matter that it's a trapezoid. It'd be the exact same thing whether it's a triangle, rectangle, square, whatever. You take the scale factor of how many times greater one side is, each side is compared to its corresponding side in the other, and you square that, and then you would multiply it by the area. All right, next up, number 11, we have a quadratic function. It's actually in vertex form, and it wants to know which of these has no x-intercepts. So, here is how I would think about this one. This is a quadratic function of parabola, and its vertex is at -1, -9, because it's an x plus h squared minus 9. Sorry, minus k. So h is -1, k is -9. Okay, so if you think about graphing that out, -1, -9, whatever, way down here. Okay, so it has some x-intercepts up here, blah, blah, whatever. Okay, for this to not cross the x-axis, it's going to need to be shifted up more than 9 units. If you shift it up exactly 9 units, it would be right on the x-axis. So it's going to need to have a vertical shift of more than 9 units. So when you look at the answer choices, answer choice D is the one that clearly matches this. You take the original function and you're technically shifting it up 11 units. C is a shift down 11 units. That would not help us. And A and B are just shifts of A is going to be to the right 2, B is going to be to the left 2, but that's not going to help us. They're still going to have x-intercepts. They're just going to be moved over left and right. So those are not correct either. Correct answer is going to be letter D. In question number 12, you're given the equation of a circle, and they want to know what the area of it is. So first we have to put this circle in standard form, then we can get its radius, and then we can get its area. So to put it in standard form, you just have to complete the square. So the way that works is, of course, you take the number in front of just the x term, and you take half of it, basically b over 2, and then you square that, and that goes in a blank on the left, and it also gets added to the right. And similarly, we do the same thing with the y term, -6 over 2, which is -3. We square that, we get 9. That adds to the left, and it also adds to the right. Now, technically, if you're doing this test, you wouldn't need to do anything else with the left side because they don't ask about the center of it. But just to show you, it would end up being x minus 5 squared plus y minus 3 squared. So its center is going to be at 5, 3. Now, on the right side, if you add up 30 plus 25 plus 9, that is 64. And remember, for standard form for a circle, it's equal to r squared. That means the radius, which will be the square root of r squared, is equal to 8. So now we can go to the formula for area of a circle, pi r squared, and we could just plug in 8. and it's going to be 64 pi. Correct answer is going to be letter D. All right, in 13, basically here you are taking this rational expression and you're doing division on it. You can either do synthetic division or long division. I'll probably just, I guess I'll show both. So if you do synthetic division, which is going to be quicker, we'd put a -5 out front, and then we have a 1, 1, 0, across the top for the coefficients. Drop down a 1. -5 times 1 is -5. Add down the columns, -4. -5 times -4 is +20. Add a 20. So now this is going to be x. This -4 is just a number, and this 20 is the remainder that goes over the x plus 5. So notice it says this expression can be written as a plus 20 over x plus 5. So a is basically everything not including the 20. So that's just going to be x minus 4. Correct answer is going to be letter A. If you wanted to do long division instead, well, you could just write it out like this. X squared plus x plus 0. We'd multiply by x times x to match x squared. X times 5 makes 5x. Change the signs both to negative. Cancels. Minus 4x plus 0. Now, -4 times x, -4x. -4 times 5, -20. Change the signs both to positive. Remainder is 20. And again, you get the same thing. X minus 4 is your answer in front of the 20 over x plus 5 part. All right, for question number 14, this one there's two ways you could solve it. The first way is to go ahead and basically multiply on both sides by the common denominator. So what I would do is I would say I'm going to multiply by C, D, E, F on both sides. C, D, E, F. Okay, all those variables put together. So on the left side, you're going to get D, E, F. And then for the here, since technically it's in parentheses, you're going to distribute. You're going to get C, E, F. Then the next one's going to be C, D, F. Third one's going to be C, D, E. Now, to solve for C, because there's multiple terms, what you technically have to do is you have to factor out a C as a common factor. And if you do that, you're then left with EF plus DF plus DE, DEF, and then you can divide by this entire long expression, EF plus DF plus DC. So, looks like the correct answer is going to be letter D for this one. DEF over DE plus DF plus EF. GE, wait, there's something is, wait, sorry, I wrote something incorrect here. One slight change. This last one should be DE, not D. This is supposed to be DE, not DC. It's DE, DE, DE. Okay. So my terms are not in the same order on the bottom, but, addition's commutative, so you can just flip them and get that. Okay. Second way you could do this is you could choose picking numbers. I won't spend the time going through all of the possible solutions, but what I would do is I would let D equal 2, E equal 3, F equal 4. So I've got 1/2 plus 1/3 plus 1/4. You get all of those to 12 with a common denominator. You've got 6 over 12 plus 4 over 12 plus 3 over 12. Now you add them all up. You've got 13 over 12. Okay. So that means 1 over C equals 13 over 12. But technically, whenever you have like a proportion like this, you can just flip it. I mean, you could go ahead and cross multiply it or whatever if you wanted to, but you can also just flip it and recognize that C is just going to equal 12 over 13. So now I know what C is equal to. It's 12 over 13. So I go through the answers and I see, okay, in A, C is equal to 2 plus 3 plus 4. Is that 12 over 13? No. In B, it's 2 times 3 is 6 times 4. B is going to be 24 over 2 plus 3 plus 4. 9. 24 over 9. Is that 12 over 13? No. C, that's going to be the opposite, which is 9 over 24, because same terms, just flipped. No. So it's going to be D by process of elimination, but just to confirm, it's 2 times 3 times 4, which is 24. And on the bottom, if you work the whole thing out, it's going to be 26 for DE plus DF plus EF, and that just reduces to 12 over 13, which is the number we got over here. And that's a second alternate way you could solve this using picking numbers. All right, now for 15, here you're given a situation about, renting a bicycle. $8 for the first hour, $4 for each additional hour. Which of the following gives the cost for H hours where H, okay. So the easiest way I found to do this was just using picking numbers. So like, let's say you rent this bicycle for 3 hours, okay? The total cost should be $8 for hour 1, plus $4 for hour 2, plus $4 for hour 3, 8 plus 4, 12 plus 4, okay, $16. So when you plug in 3 to these answer choices, which one of them gives you 16 as the answer? So 8 times 3 is 24. 24 minus 4 is 20. Wrong. 8 times 3 is 24 plus 12, 36. Wrong. Next, 4 times 3, 12 plus 8, 20. Wrong. Looks like it's going to be D. 4 times 3, 12. 12 plus 4, 16. So letter D is the correct answer. And again, I use picking numbers to get it. However, here's the actual mathematical, kind of way that you actually set up the equation. Basically, the cost is $8 for hour 1 plus $4 for each additional hour. So the number of additional hours is equal to H minus 1, okay, because you have to subtract off the first hour. That's already counted with the 8. So this is the formula, and then if you just simplify this, 8 plus 4H minus 4, it just becomes 4H plus 4. That matches letter D. All right, now to 16, the first of the grid ends. Just a basic linear equation to solve. Distribute on the right side, 2r equals 3, and you should get r equal to 3 over 2. So you could grid in 3 halves. You could also grid in 1.5. Either would be correct. For 17, this one is basically a form of a quadratic. So you could just let u equal 3x if you're familiar with u substitutions. And then it's just u squared minus 4u minus 12 equals 0. Solve it by factoring u minus 6, u plus 2, u equals 6, or u equals negative 2. Okay, we want the positive solution, so we can ignore this. And then you could say, okay, well, u is 3x, so 3x equals 6. So then x has to just equal 2. So correct answer you're going to grid in is 2. If you're not familiar with u substitutions or not sure how to do that, you could instead just multiply this all out, and you could make it 9x squared minus 12x minus 12. Now, if you go to solve this, I would factor out a 3 first. I would make it 3x squared minus 4x minus 4. And now as you're working on this, basically the way it's going to factor is going to be 3x and x minus 2 plus 2. Yes, and then you get two answers, x equals 2 or x equals negative 2/3. They only want the positive one, so we can discard this. So again, you get the same answer. That's just an alternate way, again, if you're not familiar with u substitutions. All right, top of the last page, number 18. Here we have a line, and we are told line J is perpendicular to it. So that means line J will have a slope which is the opposite reciprocal of whatever the slope of line K is. So let's see, line K, they've already kind of highlighted 2 points here. So we start here, we go down 1, 2, so down 2, and then we go to the right, 1, 2, 3, 4, 5. So the slope of line K is negative 2 over 5. Opposite reciprocal of that's going to be 5 over 2, and it's positive. So correct answer is 5/2, or you could also grid in 2.5 as well. Now for 19, here you have an exponential function, and they tell you its intercept is 0, 2, and they want to find the value of k. So all we're going to do is plug in the y value for y, the x value for the intercept, which is 0 for x, and then just solve this equation out for k. So 1/2 to the 0 is just 1. Negative 14 times 1 is negative 14. So k is just going to equal 16. That's it. Correct answer. No other work is needed. All right, number 20. This is probably, most difficult question on the test. We have a square inscribed in a circle. So first, okay, we draw a circle. Now, we've got a square inside here. So ignore the poor drawing, but assume it's inscribed properly. Here's our center, and it tells us the radius of the circle is x root 2 inches. What's the value of x? Okay, so here's the radius of the circle, and what ends up happening is two of the radii together, i.e. a diameter, end up creating the diagonal of the square. Okay, they also tell us the perimeter of the square is 30 inches. So perimeter of a square, let's say each side in the square is s, okay, is equal to 30. That means each side in the square is just 30 divided by 4, which is like 15 over 2, or 7.5. Now, for this diagonal of the square, it's x root 2 plus x root 2. So if you add those together, it's technically 2x root 2. Okay? Now, so what basically ends up happening is, like we know this, I'm going to use the fraction rather than decimal. We know this is 15, over 2. And when you have a square and you cut it in half in your diagonal, it makes 2 45, 45, 90 triangles. And the relationship of the sides is basically like x root 2. So the point is, the value of the hypotenuse is root 2 times the length of the sides, each of the legs, excuse me. So we have 15 root 2, okay, for one of the legs. We multiply that by root 2, and that means that the hypotenuse, i.e. the diagonal, is equal to 15 halves root 2. Okay, so that is the length of this entire side right here. 15 root 2 over 2. Now, we also know that in terms of variables, or in terms of x, this is equal to 2x root 2. Okay, because we solved that out. So basically now you're setting these two quantities equal, one a numerical value that we got from the perimeter of the square, the other an expression that we got from telling us, the radius is equal to x root 2, and we're just going to solve this for x because that's what we're trying to figure out. So notice the root 2's are just going to cancel, so those just drop out. So we really have 15 halves equal to 2x, and then you just divide by 2, x ends up equaling 15 over 4. Or if you wanted to do it as a decimal, so you could grid in 15 over 4, or as a decimal, you could also grid in 3.75. So either would be acceptable, but that's what the value of x itself is. Okay, again, 15 over 4, 3.75. So this was the no calculator section to the October 2023 QAS, basically the last paper SAT QAS in the United States. If you have any questions or comments, please do leave them below. Otherwise, if you like this video, again, give it a thumbs up. Subscribe to my channel, sign up for notifications. Also, be on the lookout for the solutions to the calculator section of this same exam. And otherwise, I will have more digital SAT content, popping up on my channel soon as well.